So let's go ahead and I wanted to look over this quiz with everybody just because I feel like I didn't really teach it all that well and then everything went crazy. So I just wanted to give you a chance to get all the points for this if you want to watch this video and follow along. I'm basically giving you the answers. So for a first class lever, we are looking at where the forces are inputted and outputted, and these are all examples of first class levers. But the thing they all have in common is that the output and input forces are opposite the fulcrum from the output force. Here, the output force is greater than the input force because this arm is so much bigger than this one. And so it has a mechanical advantage greater than 1. This is the opposite, has a mechanical advantage between 0 and 1, and this has a mechanical advantage of 1. So it could either be a greater output force like this, a smaller output force like this, or an equal one. So that's our answer, greater than, less than, or equal to. Okay, looking at the second class lever, there's only one diagram for this one. Here we have the input force on the other side of the lever arm from the fulcrum. So that would be opposite the fulcrum, that first answer. The output force is then somewhere between the input force and the fulcrum. And because it's always between the two, it's always going to have a shorter arm than the input arm. So that means it's always going to have a greater output force than the input force. Okay, because it's always going to go a smaller distance, regardless of where along this is. This is going to be much further. Okay, third kind is a third class lever that is basically the opposite of the second class. And so the input force is going to be between the fulcrum and the output force. Output force is over here, and the fulcrum is here, and the input force is anywhere in the middle here. And because of that, the output arm is always going to be bigger than the input arm, so that means that the output force is going to be smaller than the input force. On to pulleys. So a fixed pulley looks like this, where you have a force in being applied downward. So that's what we're going to put here. Okay. And then the output force, we're going to assume ideal mechanical advantage. It's going to be equal to the input force. Okay. So this really does not give you a mechanical advantage. The other kind is a movable pulley. So you have an anchor up there, and then the rope goes down to a pulley that's fixed to the load so it can move, and then your input force is where you're pulling up like that. And so the input force is applied upward. And then because it's splitting that load between the two ropes, it's going to be twice, the output force is twice the input force. And this is just single pulleys. If you're using multiple pulleys, you can get more complicated things. Look at my pulleys video for more detail on that. Okay, last bit. Inclined plane looks like this. You have the input force is going up the ramp here. Okay, so that's going to be along the incline. The output force is always going to be greater than the input force. You can't get less output than input. The output is just the weight of the box, so the force of gravity here, because that's how much you'd have to lift it without the inclined plane. Okay, next up is the wheel and axle. So I have two situations to look at here. Here we have where the wheel is where you're applying an input force and the axle is your output force. This is something like a screwdriver where you have the larger handle and the smaller shaft. And then over here is the opposite, where you're applying an input force on the axle and the output force is on the wheel. This is what your car axle does. Your engine applies a big force to your axle, and that turns into a smaller force, but over a greater distance, which is what you want when you're driving a car, is to get distance over time, which is speed, right? So it could be either the edge of the wheel or the axle. Okay, and that means it could be either greater than or less than. Here we're getting less output force. Here we're getting more output force. All right, next up, wedge. Here, the output force is going to be approximately perpendicular to the input force. So here we have the in is going up and down, and the output is outward, left and right. Okay, think about like an axe or a knife, something like that. And just like an inclined plane, it's always going to be greater. You can't get less output force using a wedge like this. Okay, and then the last one is a screw. So the screw is, you're applying a rotational force, but that force is going to be basically perpendicular to the axis of the screw. So the axis of the screw is up and down, and then you're applying a force along this perpendicular plane in a rotational manner. And then the output force is upward, which seems weird. Like, well, if the force is up, why is it going into the board or whatever? And there's a simple reason for that. It goes back to Newton's third law. The action force is the screw pushing on the, let's say, wood, and then the reaction force is the wood pushing back on the screw, and that's what drives it into the wood. Okay, and then just like the other variants of an inclined plane, like the wedge, this is always going to have a greater output force than input force. So that's it. Let's see if I got 100%. Be real embarrassing if I didn't. It's 10 out of 10. That's what we're talking about. All right, so check out my other simple machine videos for more information, but this is, yeah, I wanted to make sure you were able to get the points on this thing.